Hello friends, so in this video we are going to see the numerical on a duct. So here we are considering the duct as a circular duct. So the statement is given over here: design a circular duct to carry 180 cm of air with a friction loss in mm of water per meter length as 0.1. Use the friction chart for a circular duct. Take the diameter of this duct as the equivalent diameter and design a rectangular duct to carry the same quantity of air assuming aspect ratio as 1. Okay, so this is the statement given. We'll just note down the given data first of all, one by one. So given data. Okay, so what is given over here? 180 cmm. So 180 cmm is the volume flow rate is given. So where cmm stands for the cubic meter per minute. Okay, so it's a volume flow rate or the air flow rate, which is nothing but the cube. It is 180 meter cube per minute, which is equal to, if I divide it by 60, I will get this answer in meter cube per second. So 180 divided by 60, which is equal to 3 meter cube per second. So this is the volume flow rate given, and they have given the friction loss in mm of water per meter length as 1. So F value is given as 0.1, that is the friction loss. We are supposed to use the friction chart, okay, which is for the circular duct. Take the diameter of this duct as the equivalent diameter. So whatever diameter we will find by using this particular chart will be the equivalent diameter, and from the equivalent diameter we are supposed to design a rectangular duct, okay, which will be carrying the same quantity of air. So the Q will remain same for duct, for the circular as well as rectangular duct. They are saying that the assume aspect ratio as 1. So it is A by B is equal to 1, where we have already seen A by B aspect ratio, where A is the long side or the longer side. This is the A. Okay, this is the rectangular duct cross section I have drawn, and this is the B. So A and B, this is the longer side, this is the shorter side. So the ratio of longer side to the shorter side, that is nothing but the aspect ratio, which is equal to 1, and hence I can write that A is equal to B. Basically here the both sides are same. It's a square duct, to be precise. Instead of it is the rectangular duct, it's a square duct given. Fine. Okay, now what we will be doing, we are supposed to find out first the equivalent diameter. Okay, because I know the equation for the equivalent diameter. Once I get the equivalent diameter, from the equivalent diameter I can get what are the dimensions of the rectangular duct or the square duct, which is A and B. Okay, so we know that the equation for equivalent diameter D is equal to 1.265 into A cube B cube divided by A plus B raised to 1 by 5. So this is the equivalent diameter equation for same quantity, of air. Okay, so there are two equations. One is for the velocity, same velocity, and other is for the same quantity. Fine. So this is the equation for the same quantity. Now if I am able to get this particular diameter D, then easily I can get what the values of A and B, which is the required thing over here. Now to get the value of D, I will make use of the friction chart. Okay, so here is the friction chart given. So in the friction chart, y-axis is given as the air volume in meter cube per second. So this is nothing but the value Q. Okay, in our case, and this is the friction loss in mm of water per meter length, that is nothing but the value F. So here, if you go back to the numerical statement, the Q value is 3 meter cube per second, and the F is 0.1. So with respect to 3 meter cube per second, so this is the line for 3 meter cube per second. This is the line for 3 meter cube per second. Okay, and the friction loss is 0.1 mm of water per meter length. So this is what the line. Wherever these two lines are intersecting, that is this point. With respect to this point, I supposed to find out what the diameter D is. Okay, now if you see the slant lines over here, see this is what the diameter lines. Okay, 100 mm dia pipe. This is 125, 150 likewise. So here if I go here somewhere, it is you can see the diameter is about 700. This is about 700 mm. So diameter is 700 mm. Okay, fine. So from the friction chart, from friction chart, the diameter D is equal to 700 mm. Okay, so I want these values of A and B in meter, so I'll just convert this 700 mm to meter, so it is 0.7 meter. Now simply what I'm going to do, I'll just put the value of D over here as 0.7 and is equal to 1.265. Now here A and B, two unknowns are there, but equation is 1. So I will replace this B either by A or A by B. Okay, anything I can do, fine. So I'm just replacing this A is equal to B, so I'll replace the B A over here. So B cube into B cube divided by B plus B raised to 1 by 5. Okay, so simply now there is one equation and one unknown. If you solve this, you will get this particular answer for B is equal to 0.55 meter. Okay, and A is equal to B, so therefore A is also equal to 0.55 meters. So this is how you can find out the dimensions for the rectangular duct, or you can design the rectangular duct if you know the volume flow rate and the friction loss per mm of water is given per meter length. Okay, fine, thank you.